Hi everyone, my name is Saul, and we're going to talk about performance Python. This is an iteration on a talk called Speed Without Drag. It has turned into Speed with Some Drag, and we'll see why. Quick raise of hands, who here went to PyGotham this year? PyGotham? No one? Really? Oh, there's one. Okay. Good. That's good, because this is 70% of this talk is a talk I gave at PyGotham, so it's a good thing you guys didn't attend. Cool. But before that, the one thing I've learned from James Powell is that you should talk about yourself a lot. So I'm going to tell you who I am first. My name is Saul. I'm a Spaniard in New York. There's a joke about Sting there, about the song, Englishman in New York. I tried to crack it in Germany. I tried to crack it in Spain. It never works, so I'm not going to try, because I keep making enemies. Anyway, my background is in EE, electronics, and then also computer science, because I did electronics, then I figured out I actually wanted to code, so I went back to school for comp sci. Really smart. I work in EdTech as a previous speaker. I work at Thinkful, and we're actually doing things in a similar way they're doing it. In fact, we just released an Introduction to Data Science course in Python, so check it out if you're interested in that. And before that, I used to work on AdTech, advertising, Facebook advertising, because we all know the world needs more of that. So I did that for a couple of years, and that's where the data in my PyData comes from. You can find me on that email. You can tweet at me at that handle, or if you want to see the slides, the IPython notebook behind this, that fuels this talk, it's actually on PyData New York City Speed with Some Drag talk. I did lose the PSD I was using to build this little slide, and between giving you a out-of-date IPython notebook or not giving you that really beautiful drawing of myself, had I been born a llama, I chose to keep the llama. Anyway. So, by now you're probably wondering, why are we here and why are we talking about all this? The origin for this talk it's twofold. I was talking about Numba before, and also I joined a company where I had a couple folks, Ruby folks, one JavaScript folk. One JavaScript guide. It's always the JavaScript ones that are like, And, they say some things. Who here has ever heard that old saying, oh, you can't do that with Python. Python's just too slow. Who here has reacted aggressively to that? All right, so I'm going to give you a couple arguments so you can react aggressively next time. Some smartass claims that. We're going to talk about how to speed up numerical Python when you don't actually want to waste time. But first, I'm going to tell you not to do it, because I'm from the north of Spain, and we have this habit of being ambiguous. So I'm going to tell you, don't do it. There ain't no such thing as a free lunch. There ain't no such thing as a free speed up, and we'll see. These libraries will help you, but it comes at a cost. Small, but it comes at a cost. That's why we went from without drag to some drag. So think first, and then just don't do it. Don't try. You can think things through and refactor your code, and we'll see a couple ways of doing that. A couple things to like think before you go all the way down to porting your code base to PyPy. Jeff Bezos' favorite, throw money at the problem. buy more machines, clusterize all the things, and just don't try to fix Python. Just let the CRO deal with it, basically. Evaluate the cost of opportunity, because as I'm saying, it's not entirely free, so you probably want to figure out whether or not things are worth it, or maybe you would rather be doing something else. And another joke that doesn't really work is blame it on ROSM and switch to Java. Not a good one at PyData. So on exhausting CPython, I'm not using these libraries I'm talking about. I urge you to first look at your problem. One of them, if you do engineering process as it's supposed to, you should be profiling your code and doing things so that you actually know what the problem is your code has. There's a bunch of stuff like I/O, waiting for the database, serialization, many problems your code can have that this won't help you with. This library, speeding numerical Python won't help you if you're just waiting for Postgres to come back to you. So definitely look into that. There are bloopers that you can do while writing code, such as recompiling over and over again regex. And sometimes, your optimizer, your whatever won't catch that. So read your code, profile it, make sure that you're doing what you should be doing. If you're discarding any computation, just don't do it. If your front end's going to show an integer, there's no good reason to be using decimals not decimals, but doubles in the back end. Sometimes you use some randoms that you don't need to use because you would be okay with pseudo random stuff. Many other things. This is not the talk for it, but there are many things that you should do before you actually try using the libraries we're going to talk about. I include a link there to a talk by David Shachta on speeding up programs. Really interesting, completely the opposite of this talk. His talk would basically be speed with a lot of drag, but for good. Really interesting talk, really good talk. I recommend you watch it. And then capture the low-hanging fruit, use multiprocessing, careful with the overhead and Amdahl's law. Check many things, like proper use of data structures, use the language fully, use fast append comprehensions, use generators. For those of you in New York, don't use this code. But this is not really what we came here to talk about. And what we're going to discuss is what libraries and tools you have to safely escape the safety of Python, which basically means that at the end of the day, what these libraries will help you do is step out of Python or step out to a different Python that's built in a different way so that your code, your algorithm is actually much faster. We've got many tools for that, and this is the outline we have. Exhausting CPython is basically what I was talking about just not using any of the rest. Then we have a cluster of libraries that basically drop down to C, Fortran, C++, CUDA even, in order to escape that CPython that might not be that fast. Then we have Parakeet in between these two groups. Parakeet started being like Numba and Python, but turned into C, I guess, OpenMP. Although I believe it's not maintained anymore or it's on hiatus. Then we have Numba and Python, which basically not necessarily escape Python as much as just use a different backend to translate it to machine code. For those of you familiar, they use LLVM. And then we've got PyPy and NumPyPy with it. That's a complete different compiler. And Jython, which is Python on top of the JVM, which is basically, again, using a different backend. We're going to go through some examples really quickly without looking too much into the performance stats, and there's a reason for that. We're going to use this example, which is one of my former favorite interview questions, which is, given a list of coordinates for a polygon, return its area. The goal of the interview question is not to test your math, but basically your Googling skills and your coding skills. So we're going to try to speed this up. Again, we're not going to be looking too much into the performance numbers. They're there to help us discern if things are working or not. But in any case, this is just one example. Some libraries will do well, some libraries won't. So basically, grain of salt. Don't read too much into the numbers, especially when there's just one single piece of code. A library that's really good at doing GPU stuff probably won't work well, and where some others will excel. So there's that. The solution in CPython, well, before the solution, we need to actually generate these polygons. So what I wrote was a really good looking piece of code here that returns a list of coordinates for a polygon that looks like a staircase, like a diagonal, like that thing I drew in the comment. And this is beautiful code that works. I don't know how. When someone writes code this ugly, some people write a talk and tell you not to use this code. I test it and put it in production. So that's what I do. The code is tested and it works. And this is actually the solution to it, to the actual problem. This is the code we're going to be speeding up, or the algorithm, rather. It's basically the summation of the 2x2 determinants of the ordered coordinates. This is, I can't remember, this is called the shoelace formula. It's a reduction of Gauss' theorem, which in turn it's a simplification of Green's theorem, and if you want to look into it, have at it. But it's pretty solid math. Anyway, we test that with a diagonal that's 200,000 blocks tall, and we take 1/4 of a second, and then we're going to start testing these new libraries. SciPy, we all know SciPy. SciPy is a community. It's a stack. It's an ecosystem. It used to be a library that contains many helpful functions. And then the stack includes things like NumPy, IPython, and all these things we're by now used to. We can't use SciPy, quote unquote, to solve this, but we can use NumPy, which is basically part of SciPy. As you know, it's the n-dimensional array library. Goes down to C and Fortran really fast. It needs no introduction. So when solving this with NumPy, the only thing we need to do is create a NumPy array out of that polygon we generated. And then we basically rewrite the solution, slicing the array in a pretty normal fashion. And just by doing that, we get a great speed up. I don't know what that is. I think it's 70x or something like that. So pretty brutal for pretty much no work, right? Next to it is NumExpert, which is a library partly written by my fellow countryman, Francesc Alted. And what NumExpert does is it basically feeds your processor your arrays in basically a piecemeal fashion, so that all the caches are used fully. And Saul chooses that speeds things up a lot. And then there's a bunch of stuff for the VML and the vector math library and the math kernel library. For algebra, well, not really algebra, more complex math. In general, if numExpr supports what you're doing, you will see a performance improvement over NumPy. In our case, we simply write the calculation we're doing, and with that we get 4x over NumPy. So there's that. Theanu, this is the library, probably one of the most mature libraries, but the one that probably won't do as well here, because it's mostly aimed to do GPU processing, CUDA, and clusters and stuff like that. It kind of works. As you can see here, things change a little bit more. We're talking about vectors and tensors, but the general look of the thing remains pretty much the same. And when benchmarking, we get an improvement over CPython, but NumPy and numExpr are still faster. Depending on what you're doing, this will probably outpace them at some point. Then we've got Python, which is basically a C++ transpiler. Python will read your Python code and translate it into C++. They do a bunch of optimization that's native to them, SIMD instructions. Pretty interesting library, not that well known, but definitely interesting. There's a talk by Mehdi Amini from PyData Silicon Valley this year. That's interesting if this piques your interest. This is an example of how it works. You basically annotate your code, and then you run it with Python. Parakeet, as I was saying, had originally an LLVM backend. Anyone here know what LLVM is? Okay, some hands. LLVM is it's a big project, but mostly it's an optimizer and a backend compiler to different platforms. What that means is that if you know how to speak LLVM, you can actually tell LLVM to compile things to machine code for many platforms for free, and it's really fast. It's something that was partly built at Apple. You might have heard of Swift. Swift is the new iOS programming language is built on top of that. There are many things built on top of it. It's a really interesting project. Anyway, Parakeet started with an LLVM backend that eventually got deprecated in favor of C and OpenMP. I think, I don't know if Alex Rubenstein is here, but I think it's the development might have stopped. In any case, what we do here is, and it's just in time, thanks to, yeah. What we do here is decorate our code, and just we send it to Parakeet, and Parakeet returns that machine code we were talking about. Depending on the backend you choose, it will be faster or slower. In our case, you can see how it's fairly fast. The normal Python implementation can be improved. In fact, it kind of struggles with it, but the NumPy is fairly speeded up. Numba is actually, it's a library by Continuum Analytics, the sponsors. And it's basically this LLVM stuff over a subset of Python, the subset that's numeric, because if you're building strings over and over, you probably want to speed that up, but that's not numerical Python. That LLVM will help you speed up. What Numba does is exactly the same that Parakeet used to do. I actually don't know which came first, but in any case. It will read the abstract syntax tree of your code. It will translate it into this LLVM language, which is where all the work is in the library, really. And once it's in this LLVM IR for intermediate representation, it just sends it to LLVM, gets the machine code back and runs it. There's CUDA support. There's some stuff, cool stuff for static compilation, because initially this is JITted. And there's a pro version with multi-core and GPU and that kind of stuff. If you're not bored by now, by me, there's a talk about Numba on PyData last year, if you're interested. And the way this looks is exactly the same. You decorate one of your methods that includes just that subset of Python that's supported, and then you run it. And in doing that, you get a speed up for free. In this case, for this particular problem, it doesn't excel. I would expect Numba to do as well or close to Parakeet. In this case, Numba struggles with a certain thing with the arrays, which I already figured out, but I left it there for a reason, to drive a point that we will talk later. We can skip this. Numba can vectorize your methods if you're into that. It's really helpful if you use NumPy and you tend to vectorize things. That is really helpful. PyPy. PyPy is a just-in-time compiler of Python that's completely separated from CPython. This is already just, we're not trying to like circumvent CPython anymore, but we're just using another implementation of Python. It's really fast. It's pretty mature, lots of support, really worth looking into if you've never used it. In fact, I think it's the fastest thing here other than Parakeet and Numba, probably. Here we drop down to the shell. We're not running tests in our IPython notebook anymore. We're using the shoelace.py that's included in here, which is exactly the same code, same terrible, beautiful looking code. And when we run it, we get that reading. If we run it in Python, we get that reading. So you can see how PyPy is much faster using the exact same code. That's the vanilla CPython solution. There's a NumPy port. It's a fork. NumPy, as I said, basically drops down to C and Fortran. So you can't really do that in PyPy. So they have to like figure out some things and like change some things. The fork, it's getting a lot of attention and a lot of work, but it's not really good yet. But it does work. Meaning, if you have code that has NumPy, you can probably run it in PyPy if your goal is something else. That being said, at least for this example, it's the vanilla Python is faster than NumPy. That's just the code for doing that. Python is, again, not the normal Python, not CPython, which is what we tend to use, right? It's, again, a different implementation of Python. In this case, we're executing Python on top of the JVM, the Java virtual machine, which can be fast or slow. In this particular case, I think it doesn't do too... It does better than Python, but not better than PyPy. So, it's somewhere there in between. It's not I'm tempted to say it's not as mature as PyPy, but I might be wrong. But, as you can see, it's already somewhat faster than Python, than CPython, if you don't take into account the JVM startup time. This is a comparison between these ones that we tested outside of the IPython notebook. PyPy is the leading one, then NumPy, and then NumPy. And Python is a new just-in-time compiler that Guido van Rossum is working on, which is basically it's basically the same thing that Numba's doing, only they got more lofty goals and they're trying to put the entirety of Python on top of LLVM, and then they're trying to do other stuff too, especially when it comes to optimization and garbage collection and some other stuff. A huge project, really new. Doesn't even work in OS X yet. There are many parts missing. Last time I checked, they had just implemented exceptions, so definitely not production ready, but It's where the future is kind of headed in this regard. And you'll see a trend here with three basic directions. One's dropping down to C while not leaving C Python, the LLVM direction, and then the screw this, I'm going to build my own interpreter, my own front and my own back and my own optimizer, my own everything. And when all else fails, again, you can actually do the work, write C, and append it to your C Python. That link there is a GitHub repo by a gentleman called Sammy Villar that basically implemented in hardcore C using SIMD and all that stuff, the same polygon area problem. The problem with this is that it does look like this, and you have to actually write it. So, in any case, my parting thought on this is the qualifications on debt that this has, and this is why the talk changed from without drag to with some drag. The moment you start using something like this, you are introducing debt into your system to some degree. And this is going to be a seemingly obvious reminder not to trust your brain. In this room, we probably have two different types of brain. One's the scientist brain, which is like, I just want to speed up my code. I'll do whatever. I'll include a binary there. Whatever needs to be done, I'll do it. I don't care. And then we've got the other brain, that's the engineering brain, which tells you, well, it basically tells you, hey, this is really cool. We need to do this. We're going to use Theanu, Nuba, and probably Python in there too, because this is going to be awesome. I'm telling you, do not do that. There are threats to that. There's a third brain that you need to listen to, which is the software management brain, whatever you want to call it. It's probably the brain that forces a suit to work, and it's pretty stuck up. But it might have a point, which is if you start using Theanu on your production environment, and you basically do it a little bit. You basically make it work. Next summer, come May, when the new interns come, you were doing what I call your Jenga coding. The interns are going to crash into your Jenga code, and it's not going to be fun. So think about that, because one of the things I tend to say at work is think of the interns. Ain't nobody going to think of the interns. So do think about the interns on this, because this is something they will probably not enjoy. There's debt, which is that. Basically, when you leave, someone else will have to pick up your really interesting Python implementation. And then there's another thing that is not as obvious, which is the product development risk. Depending on when your project goes, depending on where you're going with your code, a solution that once seemed like it was perfect, it was, you dropping, I don't know, PyPy and everything just works. Come next month when the product guy asks you for a dashboard on this and this and that, and you have to do another group by and whatever, your code won't work anymore, and you will spend 2 months trying to make PyPy work. Or I'm not trying to target PyPy, I'm just saying, things that come for free sometimes when you just drop one of these libraries in your code base might not work as well when the next feature is asked of you. So you have to take that into account too. And to recap, it's not free. No free lunches, no free speed ups. Think first and try to avoid this. Again, don't listen to your engineering brain that tells you, hey, this is going to be awesome. We're going to be using LLVM everywhere. Use the best tool for the job. Try to figure out which of the libraries will help you the most while doing the smallest work. While using the second best tool for any job, which is Python. That's really corny. And again, don't trust your scientist or engineer brain. Trust the brain in the suit. Thank you. I don't know if we have time for questions. Yep.
I guess this is more of a comment or warning rather than a question. But you were using Jython, and so Jython only supports Python 2.6.
Yep.
And they have like beta support for 2.7, which has been in production. Like they've been developing that for 2 or 3
Yep.
years now. So I would not suggest anyone rely on
exactly.
Jython continuing to exist.
Yeah, Jython Parkit, I think, hasn't gotten a single commit since March this year. And that's why I'm saying, don't trust your engineer brain that just wants to go at it. Trust the one with the suit that tells you, hey, this library is not maintained, or hey, if we use NumPy, we won't be able to use these things that they haven't implemented yet, and that kind of thing. Because it's really easy to get really excited about getting it done or doing cool engineering things. And 6 months later, you're going to be hating yourself. The intern might hate you too, and the boss might hate you too. So, well, thank you.